Okay. We are at the Defense Manufacturing Conference in Austin, Texas. We are being joined by Dr. Robert Geer, our Director of Education and Workforce Development at AIM Photonics, and Dr. Anthony Aiello, Photonics and Test Engineer. Bob, can you briefly introduce the Hope Kits to us and explain their purpose in educating students about photonic integrated circuits?
Sure. HOPE stands for Hands-on Photonics Education. And the goal of these kits is that we can get what a photonic integrated circuit is into the hands of learners, whether they're at community colleges, four-year colleges, even learners that are currently in industry. Because although people are very familiar with integrated circuits, chips that we have in our phones and our laptops, they're less familiar with PICs, photonic integrated circuits. And considering that PICs affect almost all data that we use, whether they're from our phones or our laptops, they're used in sensor platforms, it's important that they understand exactly how they work and get some experience with them.
That's great. Can you also share your perspective on how the Hope Kits bridge the gap between theoretical learning and hands-on experience?
Well, when you talk about moving light around on a chip, as opposed to electrical current, it's hard for a lot of people, especially students, to visualize that because they're not really sure exactly where the light is, what it's doing. Having the Hope Kits, they can literally look through a microscope, see exactly where the waveguides are, where the light goes through, and more importantly, they can connect it to a light source like a laser, a detector, and they can encode information through using light and electricity. So this is an example for them to be able to see directly what these devices look like and what they do.
Anthony, would you be able to demonstrate a simple experiment or activity that students can perform using the Hope Kits?
Absolutely. And actually each Hope Kit comes with an instruction manual that students can use to guide them through each of the different chips. So for instance, this is one of the chips here, and it is composed of several different Mach-Zehnder interferometers, and some of them have thermal optic phase shifters on them. So what the students can do is they could use a tunable laser source. This one happens to be a C-band laser, and with some polarization paddles to control the polarization between TE or TM mode. And then using a simple benchtop oscilloscope and a pattern generator, they can look at the optical output by modulating one of the thermal optic phase shifters. So you can see here if we play around with the frequency, which isn't too high, but it still demonstrates the capability of the MZI to modulate the light by changing the frequency. We can effectively, change the modulation of the light. And so these are very simple experiments that students can use to understand how each component in a PIC operates. And an MZI is just one. We have photodetectors, we have couplers, splitters, ring modulators, and all of these components are used in modern day transceivers, for instance.
Bob, how do the Hope Kits fit into AIM Photonics' broader mission of developing a highly skilled workforce in integrated photonics?
Well, the goal is to, one, introduce learners, especially students, to the technology because they have no idea if it's a career they want to follow if they don't even know about it. Second is to allow them to understand a bit more about the technology that really is out there that they may be unaware of. Anthony was just talking about how this Mach-Zehnder interferometer actually is used to encode information. That happens all the time. All the information we send from our phones, from our laptops, gets encoded like that using some type of modulator, using some type of photonic modulator. And so it's critical that students understand that because going into design a chip, they could easily go in to design photonic integrated circuit. So for us, it fills a couple gaps. One, it builds awareness. Two, it allows students get a chance to get some hands-on experience so they don't feel the technology is so foreign, so far away. And once they have that, they absolutely feel empowered. So when there's a course that involves not only electronics but photonics, they're more apt to take it. They're more apt to take, say, an internship that involves this. So for us, it's a great on-ramp.
That's great. Thank you, guys.